Advanced Math Lesson 23, the exponential function and sketching exponentials. All right, so when they say exponential function, we're talking about functions that have powers. Whoops, that's really out of focus. What's going on here? There we go. So we're talking about exponents that have powers or numbers of variables to a power. And then we're also talking about exponents with radicals, because we can have fractional powers, and so that would obviously bring on a radical. So let's get straight to it, and we'll start by graphing the function of y equals 2 to the power of x. So my favorite thing to do, as you guys should know by now, when we start graphing things like this, is to pick a negative number, 0, a positive number, and see what we get. Now, as you notice with linear equations, this worked for us every time. We only had to do 3 points to figure out what our straight line was, but now we're starting to graph curvy lines and wibbly wobbly lines. So we're probably going to have to use more than these 3 numbers, but this is a good place to start. So with the graph of 2 to the exponent of x, if x is negative 2, well, then I've got 2 to the power of negative 2, which means that it's going to equal 1 over 2 squared, which is 1 over 4, so y is 1 over 4. 0, 2 to the power of 0. Well, what does that equal? 1. So then y equals 1. 2. So if I've got 2 squared, well, that's just going to equal 4. All right, so y equals 4. That's pretty straightforward. Well, let's see what this gets us. So I'll go to x is negative 2. And y is going to be 1/4. So at negative 2, we've got a spot like right there, a quarter of the way up. And then we've got when x is 0, y is 1. Hey, we've already got 1 marked off right there. Okay. And then when x is 2, y is 4. So we'll say here 2, 3, 4. Okay. What? Hold on. That looks like it's a crooked line here. So like I said, this isn't going to work. This is kind of weird. It looks like this point's off, or maybe this point's off. It's hard to see what's going on here with 3 points. So let's add in some more. We'll see what happens when x is negative 1 and positive 1. So we'll try negative 1, we'll try positive 1. 2 to the power of 1 is just going to equal 2. Or sorry, that's negative 1. So negative 1, 2 to the power of negative 1, that's going to be 1 over 2, which is 1/2. All right, and then 2 to the power of 1 is just going to equal 2. Okay, so let's fill these in. If I go to negative 1, I am now at 1/2, which is a little bit higher than 1/4. If I go to positive 1, I am now at 2, which is 1 higher than 1. Okay. All right, so now we've got a better idea of what shape we're making here. And you can think of this a lot like connect the dots. This looks like a curve. Okay, but what does my curve do? I want to know what happens as my curve approaches the right and as it approaches the left. So let's go with some big numbers. We'll go with negative 10 and positive 10. So if I have 2 to the power of negative 10, that's going to equal 1 over 2 to the power of 10. And then I'm going to use my calculator because, multiplying 2 times 2 times 2 10 times does not sound like fun, especially with all the time we have to spend on all of our other problems or our homework. And then, in case you're unfamiliar, to do powers on your calculator, you can take the number 2 as the base. So that'll show up here, right, in the screen. And then I'm going to hit this little upward house thing. Looks like a roof. That's just an arrow that points up, and it's pretty much saying, the power, the number that's up. And then I'll punch in 10. So now I've got 2 to the power of 10. Hit enter. The answer is 1,024. Whoa. Okay, way higher than what I was ready to deal with. That was a big jump. So if we go to, now that's 1 over 1,024. So if we go to negative 10, that's like really close to 0. It's like practically 0, but it's just not there yet. So it's like touching the line. Now let's try positive 10, which we already know is going to become positive 1,024. So if we go to positive 10, that's like somewhere all the way up. There's a dot up there somewhere. All right. So what we'll see is as our graph moves from the left, it's coming up from 0. It passes through 1 at 0, at x equals 0, and then as x continues to rise, the graph now exponentially rises up into the air, approaching infinity, and it's going to go up to our point up there, which is off the page. Then down here, we've got it approaching 0. So as the graph moves right, it begins to approach infinity. As it moves left, it begins to approach 0. Will it ever get there? Well, the answer is no, because we can't ever have division by 0. And as big as, we can keep pumping negative numbers into this equation infinitely. So it's just going to get infinitely smaller and smaller and smaller, but it will never become nothing. So, interesting thing about this graph is it will never reach 0. And it will move on into infinity because we can infinitely put numbers into this graph and it'll just keep going and going and going. The question is whether or not you want to. I don't want to. So let's go on to the next example. Okay, now we're going to sketch the graph of the function of x as 5 is to the power of x. Now that we know what the graph of an exponential function is going to look like, they're all going to follow that same basic curve. We could probably do this with about 3, maybe 4 points. So I'll go ahead and make my XY table. For x, we'll start off negative 2 and positive 2 just seem to be good ones for me. I like using those ones. So when I have negative 2, or 5 to the power of negative 2, that's going to equal 1 over 25. 0 is going to be 1. As any number to the power of 0 equals 1. That's going to be a common trend in these functions. And then 2 is just going to be positive 25. So what I can do here is I can actually graph this with only 3 points. I just go to, at 0, y is going to be 1. And then I'll go to positive 5. And I'll go to negative 5. Negative 5 is 1 over 25, which is really close to 0. Positive 5 is going to be 25, which, that's 25 today because I don't want to go off my paper. And that's one of the great things about minimalist graphing is you can draw graphs that are accurate even though they're not to scale. So, here's my graph. Here it comes. Curve and drastic rise. There we go. There's my graph of the function. So when you're doing minimalist graphing, you really only need to put the numbers that you're using, and this is part of the reason why, because I can represent really, really high numbers up here, so I don't have the same problem I had up here where I went off the paper. Minimalist graphs do not need to be to scale, and that's why I'll rarely count tick marks up to numbers. Most of the time I'll just put the number and tell you what the number is. So that's that. Now let's try one last example for these exponential functions. If you think you got the hang of it, that's fine. You don't have to finish this. I'm just going to do one last function. And it looks like this. 0.25 to the power of x. Whoops. I just realized you could not see that. I'm being all quiet for this dramatic drawing, and you guys are staring at white paper. Okay. So this is the last function. Like I said, if you think you got the hang of it, that's great. No need to stick around. Let's see what this one does. Take x, we'll take y. Let's go with negative 2, 0, positive 2. Now, when I take 0.25, decimals are kind of tough for me. I want to do this as a fraction. I need to make sure that I can. Yeah, I'm going to do it as a fraction. So, instead of writing 0.25, I'm just going to write y equals 1/4 to the power of x. Whoops, not 4. To the power of x. Okay. So, now, let's plug in negative 2. So 1/4 to the power of negative 2. Well, I can move that to the top to make it positive, right? Hold on. I need to pause. I'm trying to think if maybe I'm ruining this by using fractions. Give me 1 second. I just remember we have calculators. We'll use decimals. Okay. So, let's take 0.25 to the power of negative 2. Well, to make that positive, that's going to equal 1 over 0.25 squared. I'll go to my calculator and I'll punch in 0.25, and I've got two options here. I can hit the square button, x squared button here, or I can hit the exponent to the power of 2. Either one works. Exponent 2, enter, and I get 0.625. So that's going to be 0.625, pretty close to 0. When I punch in 0, 0.25 to the power of 0 is 1. Again, we see that doesn't change. Now, what about 2? If I punch in 0.25 squared, well, that's just going to be positive 0.625. Oh, wait, I forgot. That's supposed to be 1 over that. So 0.625. Hold on. Let's go to this top one. I think I might have made a mistake. If we take 1 and we divide it by 0.65, what do we get? Ah, we actually get the number 1.6. All right, so if you're doing this with decimals, be careful about these first ones, because 1 over 25 squared becomes 1 over 0.65. Divide 1 by 0.65, and we get the number 1.6. So for negative 2, that should have actually been a positive amount. That should be 1.6. Okay, now the weird thing that this does to our function is when we graph it, we know it's going to pass through 1, right? But on the positive side, at positive 2, it's actually closer to 0 than it is on the negative side at negative 2. Where at negative 2, it becomes 1.6. So it looks like it's going to rise that way. We'll just do one more test. We'll push it to the extremes. We'll go negative 10, positive 10. All right. So if we take 0.25, we put it to the power of 10. My calculator gives me 9.5367 to the exponent of negative 7. So that's like 6 zeros in front of the 9. So what that gets me is 0.123456953, etc. Very, very, very small number. So if I go to positive 10, I'm practically at 0. All right, now let's say I take 1 and I divide it by 0.123456953. I get a really, really big number. I get 1,000, or no, not 1,000, 1,049,317. Really, really big number. So what we see is, once our number becomes less than 1, our base number, if it's less than 1, the direction of the exponent switches around. So before, we were rising up to the right. Now we're rising up to the left. And that's it.